Today's goal is to switch gears a little bit from the behavioral perspective and now talk about the cognitive perspective when it comes to learning. So far we've learned about behavioral explanations for learning, including classical and operant conditioning. Now we're hopping into the cognitive school, which is going to talk about the fact that learning is more than just a product of learned associations and connecting behaviors with consequences. Um, According to cognitive psychology, some forms of learning must be explained by actual changes in our mental processes, not just changes in our behavior, like what we've talked about so far. So, cognitive psychology explains learning as a mental process. Learning, for example, might not always show itself in our behavior, but it may be taking place kind of behind the scenes. It may be reflected just in our mental activity. And we're going to talk about that in a second when we get to latent learning. So Wolfgang Köhler's research involved using chimps. One chimp in particular named Sultan was part of Köhler's research. And what he would do is he would teach Sultan individual tasks. Like here you see 3 boxes which have been moved, which have been stacked in order for him to reach this high-hanging piece of fruit. But what Köhler would do is to teach Sultan these individual behaviors, like how to move a box, how to stack a box, how to stand on top of a box. He never presented Sultan with the task, the specific task of having to reach the high-hanging fruit using the boxes. So what Sultan would have to do is take all of his previously learned behaviors and figure out a way to solve a novel problem. And that's essentially what insight learning is. If you think about the aha moment, anytime you've had an aha moment where you've really been kind of mulling over something, unsure how to solve a problem, unsure how to approach a task, and all of a sudden it just comes to you, you're able to put together all of the things that you've learned in the past related to this problem and solve it, even though you've never seen the problem before. So the fact that Sultan was able to approach a novel problem like getting this high-hanging fruit using individual tasks or putting together individual tasks that he had learned, we know that learning can't only be a product of conditioning because he had never seen this task. He had never been conditioned to complete this task or solve this problem before. And the same goes with us as human beings. We are all the time encountering new problems that we've never faced before and having to figure out a way to solve them. That means that all of our learning can't simply just be a product of conditioning. And now we're going to talk about Edward Tolman. Tolman's research, at least what we're studying of his research, is his research involving rats learning how to run a maze. So what Tolman was able to demonstrate through his research is that rats were forming what are called cognitive maps or mental representations of the mazes. We all have cognitive maps of the area in which we live, of the school that we navigate every day, of our homes. This is a mental representation that is stored in our mind that we can call on in order to help us navigate. What Tolman was able to show through his research is that learning happens even in the absence of reward. Meaning, if we think back to B.F. Skinner, Skinner says we learn because we associate our behavior with a particular consequence and we learn to repeat that behavior. But Tolman said that's not the case. So here's what he did. He took 3 groups of rats. One group of rats was taught how to run a maze, and they were rewarded every time they correctly navigated the maze. And you could see this is the number of trials. There was 1 trial per day for 17 days, and here's the average number of errors. So here's our group that was rewarded every time they correctly ran the maze. And you see like there's a decrease in their average number of errors. It's pretty steady. Okay. Then we had a group that there was no reward. They might have been given like a small reward for getting out of the maze, but like nothing really substantial that was motivating their learning. Or so you could see here, look at their average errors. We see a drop off, but nowhere near the drop off that we saw from the reward group. But here's where things get interesting. It's this delayed reward group. So these rats received no reward for the first 10 days. Then on the 11th day, a reward was introduced. And look at what happens to their average number of errors. It drops off steeply. Now, in order for their average number of errors in the maze to drop so steeply, what Tolman concluded is learning was happening all along the way. They just never had the motivation to show it. They never had the incentive to show it because there wasn't a reward being introduced. Okay? So if you're following me, what this is showing us is that whereas Skinner would say learning only takes place when there is a reward present, Tolman says, nope, learning is a mental process that is taking place in the brain and that might not show itself in our behavior. Just like with these rats that were learning all along, but didn't actually show it until they had the incentive. Okay? So learning was happening all along the way, an incentive is introduced, and all of a sudden we see a really steep drop in their number of errors because they had been learning all along. So this is called latent learning. Latent means like below the surface, underlying. So even without reinforcement, rats who had time to explore the maze, even without a reward, navigated much more quickly and with fewer errors when the reinforcement of the reward was introduced. This should actually say, I believe, on the 11th day instead of on the 10th day. But anyway, so the significance of this is a challenge to behaviorism. Learning happens even when it isn't being demonstrated in a way that's observable. Back to our discussion of cognitive maps, that's what the rats had been learning, these cognitive maps of the maze. Research shows involvement of the hippocampus. When we learn a spatial layout, it's our hippocampus that is involved. There was a study that was done of London taxi drivers, I believe in the late 70s, and they found that when they did MRIs of these taxi drivers, their hippocampi were much larger on average than the average person. Now, of course, today we have GPS, but back then, think of someone having to have like a very robust cognitive map or mental representation of the entire city of London. So it's a hippocampus that's involved in the creation of those types of cognitive maps.